Good morning all of you. Today we are going to discuss about the purification of water supplies. As you know, the available raw water must be treated and purified before they can be supplied to the general public for their domestic, industrial or any other uses. And the extent of treatment required to be given to a particular water will depends upon the quality and characteristic of available water. Okay, and also it will depends upon the quality requirement for the intended use. So there are various methods or techniques are adopted for purifying the public water supplies. So water treatment is defined as the process of removing all those substances, whether biological, chemical or physical, which are dangerous or undesirable in water supply for human and domestic use. So next is what is the objective of water treatment? So in the objective of water treatment are in order to remove the pathogenic organism and consequently it will consequently prevent the waterborne diseases. And next one is to remove the substances which impart color, taste and odor to water, to remove excess or undesirable chemicals from water, and to regulate the essential elements that may be excess or lacking in a certain water supply. Next, what are the different methods of purification of water? So the various methods or the techniques which may be adopted for purifying the public water supplies are screening, plain sedimentation, sedimentation with coagulation, filtration, disinfection, aeration and softening. So let us first discuss about the screening. So screens are generally provided in front of the pumps or the intake valve so as to exclude the large size particles such as debris, animals, trees, branches, bushes, etc. So this is you can see this one is the image of a screen. This is the plan and section. So there are two types of screen. One is coarse screen, second one is fine screen. The coarse screen are sometimes placed in front of the fine screens, and the coarse screens are consisting of parallel iron rods which are placed vertically or at a slight slope at about 2.5 to 5 centimeter apart. So you can see here these are the iron rods, and the fine screens are made up of woven wire mesh with openings not more than 6 mm square. The coarse screen will first remove the bigger floating bodies, and the fine screen then remove the fine suspended solids. The fine screens normally get clogged and are to be cleaned frequently. The fine screen are therefore avoided in these days, and the finer particles are separated in sedimentation process. The core screens are generally kept inclined at an angle of 45 to 60 degree to the horizontal, so as to increase the opening area and to reduce the flow velocity. And while designing the screens, clear openings should have sufficient total area so that velocity through them is not more than 0.8 to 1 meter per second. Then the material which is collected on the upstream side of the screen is removed by manually or mechanically. So this is all about the screening. Then next come to the next process, that is plane sedimentation. So let us now discuss about the principle behind sedimentation. So most of the suspended impurities that are present in water are having specific gravity greater than water. So in still water, these impurities tend to settle down under gravity. But in normal water supplies, they remain in suspension because of the turbulence in water. Hence, when the turbulence is retarded or reduced by offering storage to water, these impurities tend to settle down at the bottom of the tank. So this is the principle behind sedimentation. And the basin or tank in which the flow of water is reduced is called settling tank or sedimentation tank or sedimentation basin. And the theoretical average time for which the water is detained in the tank is called detention period. So next, let us discuss about the theory of sedimentation. The settlement of the particle in water depends upon the three different factors, that are velocity of flow, viscosity of water, and third one is size, shape and specific gravity of the particle. So let us first discuss about the velocity of flow and how it will affect the settlement. So the velocity of flow will carry the particles horizontally. The greater the flow area, the lesser is the velocity, and hence more easily the particles will settle down. The next one is viscosity of water. The viscosity varies inversely with temperature. Therefore, warm water is less viscous, and this will offer, so warm water is less viscous and therefore it will offer less resistance to settlement of particle. But it is not possible to control the temperature of water, and hence this factor is generally ignored. Then next factor is size, shape and specific gravity of the particle. So the greater is the specific gravity, the more rapidly the particle will settle. The size and shape of the particle also affect the settling rate, and very small sized particle therefore will settle very slowly. Okay. So the settling velocity of a spherical particle, the particles are generally considered to be, the particles that are present in water are considered to be spherical, and the settling velocity of these particles is expressed by Stokes' law, which takes the above factors into account. So let us see the Stokes' law. So this is the final Stokes equation for diameter of particle less than 0.1 mm. So this is Vs Here Vs is the velocity of settlement of particle in meter per second, equal to g by 18, and this small g will represent acceleration due to gravity. Okay, acceleration due to gravity, and whole into g minus 1. This capital G is the, this is not the small g, this one is the capital G, that is specific gravity of the particle, minus 1 whole into d square by nu. So d is the diameter of the particle in meter and nu is the kinematic viscosity of water in meter square per second. So this is all about for today's class. In the next class, we will discuss about different types of sedimentation tank. Thank you.